Good day, everybody. This is the last topic for our statistics course. We're doing ANOVA. And briefly, the history here is that William Seeley Gossett, who worked for the Guinness Brewery in Dublin, Ireland, he created the t-test. And the t-test is a really good test. We still use it today in modern statistics. We still use Gossett's t-test. But it only worked for comparing two samples, two groups to each other. And the problem was, there are research settings where we might have three samples or four samples, five different groups that we're going to compare to each other. So what Ron Fisher from the Lady Tasting Tea story, what Ron Fisher did was he said, hey, let's extend the t-test and make it work for three groups or four groups or more. Okay. And what he came up with is ANOVA. He just did the basic mathematical generalization of the t-test and came up with ANOVA. All right. So that's an acronym that stands for analysis of variance. Sorry. And the null hypothesis and alternative hypothesis, we usually write them in words. And the null hypothesis is that all of the groups have equal means, have the same average. And the alternative hypothesis is that at least one of these groups differs from the others. Okay, a different mean. Right? And the code is stats dot f underscore one way. One way ANOVA is the simplest plain vanilla version of ANOVA, so it's appropriate for this class. And notice that it requires array data, and it requires one array for each of the different groups, right? So every group is going to have its own array, its own data in array form that I have to put in to the f underscore one way procedure. Right, and our first example is from this hybrid.csv table, and we've got three different classes of cars. We've got compact cars, we've got SUVs, and we've got minivans. And the question is, is there a difference in average miles per gallon? Okay, so the null hypothesis that all three types have the same average gas mileage, and the alternative hypothesis is no, maybe they aren't all equal. Maybe one of those group means is different than the others, okay? And so we are going to then use the stats f underscore one way to run this. Let me clean that up and jump into the notebook and you can see. So we're starting at the top and let's slowly go through here and get everything running. You'll notice that we're importing the definition of group stats. So we'll have that. We're importing scipy.stats as stats. Those are the important things here. Why? Well, group stats is used in the final project and we have to use it here. So let's go over that code. I'm also going to make sure that the cars table is loaded. Okay, and then group stats. The first thing that goes into group stats is the table name, no quotes. No quotes around the table name, just the table name goes in. The second thing that goes in quotation marks is the title of the column where the grouping variable is. What are the groups? And here our groups are compact and minivan and SUV. So that's the column, class in our case. That is the grouping variable in quotation marks. We also have quotation marks around the numeric data variable of interest, the one that we're calculating the mean for and the standard deviation, right? This is miles per gallon. Okay, so what are we doing here? Well, first we're doing group stats just to see if running an ANOVA makes any sense. Does there appear to be any differences? And we're like, oh my, yes. The SUVs appear to have very different gas mileages than the other two. The compacts and the minivans aren't that different from each other, but they're certainly both different than, or they look like they must be different than the SUV. That's why it's appropriate to run this. And again, how do I run it? I just type in stats.f underscore one way, and then I enter each array. And it doesn't matter which order I type them in, but I'm going to go in the same order that they're presented up there. All right, I just type in the names of the arrays and it runs. Okay, and I get a test statistic of 73.8. and a p-value that is switched to scientific notation. So I have 3.6 times 10 to the negative 18th. Okay, so you'll see that I've summarized the results here, specifically the p-value. And what's our reporting out? Our reporting out is that since p is so small, I just use this, it's essentially zero. We know it's positive, we know it's non-zero, but it is so close to zero due to this, large negative exponent in scientific notation. We know that's a tiny, tiny number close to zero. Therefore, we reject the null, right? And we're rejecting the null. Why? Well, the null is a probability model, and the probability model was all three types of vehicles have the same average gas mileage. But the data that we saw was kind of extreme. The SUV gas mileages were very extreme and very different from the other two types. So we're rejecting the null because it's just unlikely to be true. There's a mismatch between the null hypothesis and the output we see from the experimental data. That's why we're rejecting the null, and we have evidence for the alternative, that at least one of these classes of vehicles has a different average gas mileage than the other. Okay, so in our notebook, I put basically the same thing as reporting out. And then your notebook doesn't have this post hoc testing bit, but that's what we're doing. They say, hey, the p-value is small. We rejected the null. Let's use these two sample t-tests to see where the differences lie between the vehicles. Okay, well, ANOVA in a more sophisticated statistics class is a two-phase test, and I do what we just did, and the second phase is what's called post hoc testing. And when I reject the null, post hoc testing allows me to figure out which groups are different from which groups. Okay, well, that's what we're doing here. So this is not how you do it. We use things like Tukey HSD and we use Dunnett's test, but this independent samples t-test, we know how to do that. And it's a simulated post hoc test, right? And notice that when I run the first one, what happens is p-value 0.19, excuse me, yeah, 0.19, which is greater than alpha. So I fail to reject the null. There's no evidence for a difference between gas mileage for compact, gas mileage for minivan. But look at these two p-values for SUVs. They're both scientific notation switching to negative exponents. So I know there's a difference between the SUV average gas mileage and compact and the SUV average gas mileage and the minivan. Okay. So the post hoc testing has kind of guaranteed what we said we thought might be true, that the SUV had a different average gas mileage than the other two did. All right. Um, so you can see that, I'll show you why I haven't been typing out scientific notation. To get the little x, times 10, I have to do backslash times, and then the exponent, I have to put curly brackets around because it's long and has a negative symbol. So I haven't been doing that. That's why I did the backslash sim, right, to get essentially equal to 0, because that's more difficult. The reporting out is very similar to what we said, but it includes an analysis of these values. And notice that they're using the synonym to reject the null, statistically significant. Next, they give us side-by-side box plots, and we can visually confirm what we're seeing in the data, that the SUV gas mileages were just much lower than these other two. Okay, and we now have scientific evidence of that, not just visual confirmation. What does ANOVA do? They give us the equations if I need to run it by hand. But I'll let you take a look at that in the time that you have, and then they plot it. And normally what we do is we would calculate the F statistic, then we draw a vertical line, and we would shade to the right of that vertical line where the F statistic is. But you see the F statistic is 73, and the largest values on my x-axis are 8 or 9. So this vertical line is like 7 or 8 computer screens over from the one we're looking at, right? So you can't even see. That's what it's saying, that the p-value is too small to see. It's just way, way over there to the right. Um, this is what the the F distribution does look like. It is not bell-shaped, but it has this peak early on, and then it tails off as it goes to the right. And let me clean up, and we can step forward. What do? We have the student data, and notice that we have sleep hours. So we're going to estimate, or we're going to compare the average number of hours of sleep per night that these students get. Okay. Um, there's another one that we're also going to do about fuel mileage by class of truck, but we'll talk about that in a second. And the question is, do the average number of hours of sleep vary based upon year in school? Okay. And so the null hypothesis here is that all four classes of students have the same average sleep hours, and the alternative is that at least one class has a different average, right? And we run it in the same way, but notice now, right, I have four arrays that I have to create. It wants array data in the stats f underscore one way, so I have to create a separate array for every single one of the groups. So I'll need to create four arrays. And if you look in your notebook, we have those four arrays created for us, and we've done group stats, okay? So group stats, students is the table name, college year is the title of the grouping variable column, and sleep hours is the title of the numeric variable column that we want to use. And here you go. This is going to create the students where college year is first, and then dot column sleep hours to pull out the sleep hours values as an array. So I can run stats f underscore one way, freshmen, sophomores, juniors, and seniors, close parentheses, and run it. And you can see that I get an F statistic of 0.280, and I get a p-value of 0.839. Well, that's a very large p-value, right? This p-value here is very large. As a matter of fact, it's way bigger than 0.05. So what does that mean? Right? That means that we're going to fail to reject the null. I'm sorry, I thought I had changed this. I did update this, but I guess I didn't get the new file open. So we fail to reject the null. Why? Because this is greater than. All right. And therefore, we have no evidence. So this part was right. We have no evidence for any difference in sleep hours. Why? Because we failed to reject the null. Okay, let me clean that up, get the ink off the page, and jump back into the notebook. And you can see, because what do? We create the side by side. Oh, excuse me. This is the F statistic curve. And notice that we drew this vertical line here where, well, at F equals 0.28. And we shaded to the right of it, which ended up being 83.9% of the area under the curve is shaded. Okay, clean that up. And they do the reporting out. Notice that they also say not statistically significant, where we said failed to reject the null. So reject the null and statistically significant are synonyms, and so are fail to reject and not statistically significant. And then the last thing they do here is they give us side-by-side box plots, and there was no difference that we found from our statistical test, and you can see the same thing right here. While the medians look a bit different, these golden triangle means just are not that different at all. There are some slight differences in the overall distribution, but not in the means, which are represented by those golden triangles. So we failed to reject the null. Okay, so then the last one we're doing, right? We have large pickup trucks and SUVs. Okay. And what did we do? Well, we created more arrays here than we needed, but specifically we needed truck and we needed large. An SUV was created up above. So we've got the ones we need, and we run this, and you can see that the p-value is 0.0085, which is less than alpha. So we're going to reject the null. Okay. And reporting out, this difference is statistically significant, and they report some things about how big or small the average gas mileage is. And then you can see there does appear to be a difference, and we find one statistically. All right, so that's how we do ANOVA, right? So you need to know how to set up that null and alternative hypothesis, the null hypothesis being that all group means are equal, and the alternative being that at least one of the group means is different. Then you need to know how to get the array data, put it into stats underscore one way to run the ANOVA, and then you need to know how to analyze the p-value and get the final conclusion. All right, I'll be back with another video soon. Have a great day, everybody.